All right, yesterday we left off on this page where we labeled the vertex and we said if it was minimum or maximum, and then we said what the x-intercept or what the axis of symmetry is and what the y-intercepts were. So let's go ahead and go to page, I don't really know what page this is because mine aren't numbered, but it's 8.2. 8.2. Alright, so today we're going to be talking about quadratic roots. So we're going to just keep going with what we did, where we were. And a quadratic, the definition is the points where the parabola intersects the x-axis. These roots can also be called, you might hear them called solutions, or zeros, or x-intercepts. So you can have different, you can have three different kinds of answers. You can have quadratic roots that have two solutions, one solution, or zero solutions. So when they have two solutions, that's just like a classic parabola where it passes through the x-axis two times. Okay. When it has one solution, that's when the vertex is right there on the x-axis. That's where it passes through. So that's one solution. And then when there's no solutions, it's where it either opens up above the x-axis or it opens down below the x-axis. Okay? So those are your two no solutions. So let's go down here to this problem. We're going to need your calculator, and we're going to put this into our calculator into y equals, because we know f of x is the same thing as y equals. So I'm going to put in x squared plus 4x minus 5. Oh, man, I do this all the time. You got to be careful with that exponent. You got to press over. Plus 4x minus 5. Okay, I'm going to graph that, and I'm going to sketch it. But before I sketch it, let's go ahead and go to the table, because we need to fill in this first. Okay, so I'm going to go to the table, and I want to teach you how to find the exact vertex without having to use the arrow keys to kind of scroll over and then kind of estimate. The table will tell you what the exact vertex is. So there's going to be a point where you're going to see a pattern, and you're going to see some repeating points. A 4, negative 5, 3, 8. So you're going to look at your y values. 5, 8, 9, 8, 5. So the one in the very middle of those patterns, 5, 8, 9, and then 8, 5, 0. So you'll see look at the pattern of the y's. 7, 0, negative 5, 8, 9, 8, 5, 0, 7. It's going back up and down. See here, this is the one where it's not repeating. Negative 2, negative 9. So I like to put my vertex in the very middle of the table on here. So this is my vertex. Alright, so negative 2, negative 9 was kind of in the middle of all of our repeating y's. So let's just put some, let's put the zeros on there as well. The ones that have a 0 for y. We have a negative 5 and 0 and 1 and 0. So we can just plot those points right now. We don't have to, I want this to be a little bit more exact than yesterday. So negative 5, 0 would be here. Negative 2, negative 9 is going to be down here. And 1, 0 is going to be right here. So I can now trace my parabola. You can see it looks a lot like what I have on my graph. And I don't need to, just 3 points is good. The vertex and then 2 zeros or 2 other points are good. If you have zeros, then that's good. So how many roots? Remember, a root is where it passes the x-axis. So it passes 1 time, 2 times. 2 roots, and the roots are negative 5, 0, and 1, 0. Okay, so that's how you do that one. So let's do another one. Let's do number 3. That's a negative x squared. So if you remember what a negative x squared is going to do, let's see if you can kind of think about that. But let's go ahead and put that in. Negative x squared plus 2x minus 3. I'm going to graph it. If you thought about it, negative means it opens down. It frowns because it's being negative. So now I want you to go to your table and let's look and see where it's not repeating anymore. So it looks like on your table, do you see how there's like a pattern? Negative 6, 3, 2, 3, 6. See how it's kind of going down and then back up? Well, this part where it's like in the middle, that's your vertex. That's where it's like, it's changing direction. So where there's no repeating y values is your vertex. So I'm going to put that in the middle. That's my vertex. Okay, and the point is 1 and negative 2. And then I'm going to put, let's see, are there any zeros? I do not see any zeros. Your y would have to be zeros. So it looks like this one's going to have 0 zeros. No zeros. None. You might also see it as no solutions. But let's go ahead and put some other points on our table. Maybe the ones on either side of that vertex. So 0, negative 3. Now that's a 0, but it's in the x-axis. Your 0 needs to be in the y-axis. I mean the y values. And then we had 2, negative 3. So let's plot those. 0, negative 3 would be here. And 2, negative 3 would be here. And then one, negative 2 would be here. Wait. Yeah. So see, it looks like my line. Okay, so there were no solutions to that. And on this one, if there are no solutions, we can say it's not factorable either. Alright? It only crosses the y-intercept. It does not cross this x-axis, the x-intercept. Let's go ahead and go to the back. Let's do number 5 right quick. Negative x squared plus 9. You can see that one's a little bit different. Alright, so it's going to be a negative. It's going to go down because it's negative x squared. I'm going to go to my table, and I'm looking for one that does not repeat, and it looks like it's going to be 0, 9. That's going to be my vertex in the middle here. 0 and 9. And then I do have some zeros in my y-axis. I'm going to put those. We have a negative 3, 0 and a 3, 0. Okay, so if I were to plot those, 0, negative 9 would be, or 0, 9, sorry, would be all the way up here. And then we have negative 3, 0 and 3, 0. So my line's going to look like this. How many zeros? It crosses at 2 points on the x-axis. And the zeros are going to be negative 3, 0 and 3, 0. Okay? Alright, let's go down to the bottom. The bottom says, find the solutions using your graphing calculator. So the first thing you want to do is check and make sure it's equal to 0. Check and make sure it's equal to 0. So number 7 is already set equal to 0. So I can go ahead and plug that into my calculator. So the first step is to put in calculator and graph it. And then the second step is to tell me the number of solutions. You don't have to tell me what they are. You just have to tell me how many numbers there are. How many solutions does it have? So x squared plus 5x plus 4 I'm going to graph that, and you can see here when I graph that it passes through the x-axis twice, so there are 2 solutions. Number 8 sets equal to 0 already, so you could put that in your calculator just like it is and do the same thing and tell me how many number solutions there are. And then on number 9, let's look at that one. It's not set equal to 0 yet, so we have to, before we can put this in the calculator, it has to be like this negative 25 needs to be on the other side of this equal sign. So we're going to move that guy over, and it's going to become now x squared plus 10x plus 25, because when you move something over, you do what's opposite. Like if it's negative 25, you have to add 25 to move it over. And now it's equal to 0. Now we can put that into y equals x squared plus 10x plus 25. And then graph it. And it looks like it passes at the vertex. So it's only one solution. Okay? All right. And that's it for today. Tomorrow in class we'll do the worksheet for this lesson. You'll have a good day.